Hello class, today we're doing lesson 12.4, Shape of Data Distribution. So on page 891, I want you to complete this. The distribution of a set of data shows the arrangement of data values. The words below show some of the ways the distribution of data can be described. Match the words below to their definitions. So, do you guys think cluster is A, B, C, or D? So, excellent. Most of you guys got it. So we see that right here. Cluster means data that are grouped closely together. Think of like a cluster of animals. Think of that. Think of like a group of birds or a group of people. They say don't gather in a cluster, or if you cluster together things. So a cluster is something that's all tight together. I like to think of it as when I think of an attic and all sorts of things clustering up an attic. You know, an attic is a pretty tight, confined space, so we have all of that. Now, which one do we think gap means? So do you think gap is A, B, C, or D? Excellent. Yes, most if not all of you guessed B. It is the numbers that have no data value. So think about this. You might have been told, oh, you have a gap tooth. That means you've got no tooth there. That means you have no tooth. So what about peak then? Do you think peak is A, B, C, or D? Mind you, it obviously can't be B or D, so you're kind of left with A or C. Yes, the answer is C. So a peak is the most frequently occurring value, or the mode. And now you might be thinking, okay, I don't understand that. Why is it like that? But let's think back to our line plots. When we had our line plots, it would look like this. And we would have some data values wherever, we would have our data values. And where's the peak? The peak is the highest point, right? It's where the mountain is climbing to. It's our highest point. And that means it's the part with the most data. It is our mode, as we can see. That is why that means peak. So lastly, as we all have figured out by now, symmetry means when the left side of the data distribution looks like the right side. If something is symmetrical, it looks the same on both sides. So we've covered all of the terms for the types of distribution of data. So let's see them in action. Here, the line plot shows the cost in dollars for parasailing for different companies on a certain beach. So it says draw a vertical line through the middle of the data. What do you notice? So it's asking us to find essentially the median. We're going to find the median. And as we can see, it's pretty easy because this has a cluster of 1, 2, 2. This is the threes. So obviously our middle of the data is going to be right there at that 35, right there in the middle of the data. When it asks you to draw in the middle of the data, we're not drawing it like that. Doesn't make sense. So we're drawing it like this. What do you notice about that? So let's see. Excellent. Lucy says both sides are equal. And Sophia just used our new word that we learned. She said it's symmetrical. Yes, Melanie says both sides are the same. Exactly. So we see all three of those. We see they're all the same. As Lucy said, they're equal. As Sophia, they're symmetrical. They're the same. We see all of that. So yes, it is symmetrical. It is symmetrical, or left looks like right. Now, as a side note, it doesn't have to be exactly the same. Hannah brought up a great point. She says it's mirrored. Yes, it is. If I had that right there, it'd be mirrored on either side. Now, the thing is, with data like this, it doesn't have to be exactly the same on both sides for it to be symmetrical. But if it looks symmetrical enough, if we see, okay, that both sides look about the same, close enough that from far away you really wouldn't be able to tell the difference. So use one of the words shown, we see it is symmetrical. That is one of the words shown. So, describing the shape of distribution. Data that is evenly distributed between the left and the right side have symmetric distribution. The distribution shown has a cluster of several data values within this one interval. So here is our cluster. Because there are no data values on either side, they're all grouped together. As such, we see gaps in data where there are no pieces of data there. So then, lastly, value 10 is where the peak is, because that's where the highest part of our mountain is. That would be the highest place to climb. So that's different ways. We just used 3 different words to describe this data, and we could technically use the word not symmetrical, not symmetric. So let's look at this. If we looked at this one example, so it says here, the line plot shows the temperature in degrees Fahrenheit in a city over several days. So like I said, we see this graph right here. This is that line plot or dot plot that I showed you earlier. So I'm going to ask some questions. Where do we see a cluster? We might see more than one cluster in a graph too. You might have 100 clusters. It depends on how big your data set is. So in the chat, type, where do you see clusters? Great job! So we see all of this stuff. We see if people have identified that between 16 and 18 and between 22 and 25. So those are our 2 groups of clusters. Once again, we can see more clusters than just one. So we see here that there are clusters from 16 to 18 and from 22 to 25. As such, let's talk about the gaps. Do we have any gaps in this data? Because we're going to be trying to use all 4 terms to determine the distribution of data. So do we have any gaps in this data? Excellent. So you guys have pointed out that between 19 and 21, there is a gap. I also saw Sophia with a great idea. What she did, she put a gap there at 15. Now, do we think that 15 is a gap or not? And why? I want you guys to tell me. Hannah, do you think it's a gap or not?
I don't think it's a gap because a gap is a space between 2 or more numbers on each end.
Exactly. So we see it's a space between those numbers. Liana says it starts at 15. Technically, data starts more or less at 0. You get what I'm saying? Like, it can start at the negatives. It's stuff like that. So that's technically not a gap simply because it's not between any 2 data points, and we don't know, there might not be any other data over here. If there was, if we had some data over here at 7, like this, then yeah, all of that would be a gap. Even if we had some data just right over here at like 13, and we didn't have, and we had that, and 14 even, like that could be a gap in data. But unless we see data on either side, it's not a gap. So we see that there is a gap from 19 to 21. Now, let's also talk about this. Is this graph symmetric or not symmetric? What do we think? Exactly. We got several people, almost everybody who responded, almost everybody said not symmetric. Hannah, Liana, Nathan, Emmett, Michelle, Lucy, Angelo, Isis, Melanie, Jenna, and then, and Sophia. So we got all of that. We realized that the distribution is not symmetric because the left side does not look like the right. We have way more data points on the right-hand side. There is, even if we tried to draw it down the middle of our graph, there would be not necessarily a middle. Let's see. Here's 4. Let's say, actually, here's 5 of them. Here's 5 of them. So the middle of our data would be here. And as we can see, just by looking, our 2 sides of data do not look the same at all. And then lastly, it just says, where is our peak? And this should be easy. It's not necessarily where we draw the line, but in this case, I'm just going to say it, our peak is here at 22, because that's where it has the most data values. That's exactly where we have the highest point. And then it points out that there are no outliers. We don't have any data points substantially bigger or substantially smaller than anything else. So we don't have any of those data points that are just outliers. Let's look at the second one. The box plot shows the number of visitors to a gift shop each month. Now this is something that we have to consider. With a box plot, you cannot identify gaps, peaks, and clusters. Box plots don't show exact data. They don't show the exact numbers that we hit. We make box plots from line plots. What do box plots show? What does this part represent? The amount. I want to know what that part represents. What percent, maybe? That could be a clue. Yes, Emmett and Izzy got it right. It is 25%. And as such, we know this is 25%. This is 25%, and this is 25%. 25% 4 times make 100%. We know that in our box is 50% of our data. But we can't see if there was any gaps. We can't see if there's any clusters in data. We can't see if there's any peaks in data. So what can we do? If we can't do 3 of the 4 words, then exactly as Melanie said it, we can only identify symmetry. And she pointed out each has the same side. So each box and whisker has the same length. So the data is evenly distributed. The distribution is symmetrical because it looks like the right side. Let's look at this. This is from 10 to 30. That's a range of 20. This is from 70 to 90. It's a range of 20. This is from 30 to 50. Range of 20. This is from 50 to 70. Range of 20. So they didn't all have to be 20. This could have been, both of these could have been ranges of 10, and these could have been ranges of 30. But as long as the data looks the same, if you split it up and down, then it's excellent. And as Melanie pointed out from the book, it mentions there are no outliers. When we see a box plot and we see an outlier, it's typically something way over to the side, and they mark it with an asterisk. Because we use that asterisk to be like, okay, look, it's a data point. It is there. It does count. But it also throws off our data and might not be valid. So, then we've got this one. Let's look at this line plot. Choose the appropriate measure to describe the center and spread of the distribution. Justify the response based on the shape of the distribution. So we haven't looked at the appropriate measures yet. So let's think about this. What is the distribution of this data? What's the distribution? Is it symmetric? No, not symmetric. Do we have an outlier? Do we not have an outlier? Do we have gaps? Do we have clusters? What do we have? So type your ideas into the chat. Look at this. I love this participation as we see it. We're starting at the top. Michelle says gap. Lucy says not symmetric. Liana says not symmetrical. Izzy says we have an outlier. Jenna says gaps and clusters. Marcus says gap. Lucy reiterates big gap. Nathan says gap. Sophia says cluster. Jasmine says gap. Liana says we have an outlier. Ani says cluster. And Angela goes big gap. So yes, that is true. Here's our big gap as what we see. This is an outlier because it's so exactly. We see this big cluster here, an outlier here, and a big gap here. Whenever you tend to have anything like that, what it means is that our graph is going to be not symmetric. We can already tell that it's going to be not symmetric, but whenever you have those big gaps and outliers, it's typically not symmetric. If we were to split our data in half, we're going to get rid of, those are 3 points of data. This is 3 points of data. Here's another 2 points of data, 2 points of data, 3 points of data, 3 points of data. So our middle is still this part right here at the 12. So if we were going to be doing our data, the middle falls here at that 12. Does our data look the same on either side? No, it looks different. So all of the points that you brought up, the data are not symmetric, and there is an outlier at 19. So what do you think would be a good way that we could describe this data? Think mean, median, and mode. If I wanted to see it, do we think that mean, median, or mode would be a really good way to describe the data? Excellent. So we see this. Lucy says median would be the best to describe it. I think that she's exactly right. If we went to the median and we found that our median was in 12. As such, mode would be a pretty good way to describe it too, because it's the same thing. That's not always the case though. Our median is not always the mode, which is why median is going to be the best way to describe it. Because what if our mode was this, if we had our mode here at 15 instead? it's still not next to where most of the data points are. We still have that outlier, but it's still not where most of the data points are. So mode isn't the greatest way. Median is going to be the best way to describe it. And you could use the IQR to describe it. So it says write a few sentences about it. We already figured it out. The median is 12 states. The first quartile, and what we would do, we've got this median. We cross it off. Technically, it's right there in the middle like that. So then we'd see that our first quartile, we cancel out 3 and 3. Our first quartile is 11. The third quartile, 3, 3, and then we technically have these ones left because we've got that outlier. So that third quartile, though, I canceled the wrong thing. So we got 3, and then we canceled 3 on the other side. So our third quartile is 13. So the interquartile range, by the way, is 13 to 11, the IQR, 13 minus 11, the range, or 2 states. So exactly, we see all of that happening. The data are centered around 12 states. The spread of the data around the center is about 2 states. So the data around the center is between 1 and 2 states off. That's what that center of data means. Measures of center and spread. So we're looking at this chart. If the data distribution is symmetric, if it's yes, then a good thing to use is going to be the mean. We can also use what goes along with the mean absolute deviation. So that's if the distribution is symmetric. If it's not symmetric, use the median. So that's a good thing. Symmetric, use the mean. Not symmetric, use the median. So let's do some of these practice problems. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution at the right. So this distribution. Now, here's what I want to address, okay? So, do we have any clusters? Do we have any gaps? Do we have any peaks? And then is it not, or is it not, or is it symmetric? So we see that. The not, or is it symmetric? That's what we want to see. By the way, who can tell me what this graph on the side here is called? What is the name of this graph? And no, the name is not Toby. What is the name of this graph? So I got 3 people that wrote bar graph. You are not incorrect, but as Liana said, it's a histogram. Now, the specific the difference between histograms and all bar graphs is that histograms have numbers on both sides, just like what we saw before, and that the distance between each of them is the exact same amount. So the difference here is 2 hours and 29 minutes, 2 hours and 29 minutes, 2 hours and 29 minutes between all of them. Oh, it's minutes and seconds. So it's 2 minutes and 29 seconds. So exactly, it is a histogram. We see this, and it is a histogram. So now let's see. Are there any clusters? Are there anything? Izzy says they have clusters, no gaps, a peak, and it's not symmetric. Does anybody else have anything that they want to add or contradict or say anything? Liana, what do you see?
I accidentally raised my hand.
Michelle says no cluster, no gaps, a peak, not symmetric. Lucy says no cluster because there is no separation. I'm really liking this. There is actually a cluster. I would never have thought so either, funny enough. But our data clusters here. Because look at how many more data points happen here than happen here. Just because there's no gap doesn't necessarily mean there's no cluster. It's kind of like in a classroom where if we had some amount of girls and some amount of boys. I have a class that has twice the amount of girls than boys. I'd say that's a cluster of girls. There's obviously no gap within the data. I don't have a gap of between boys and girls because they're there. So even though there are no gaps, there are still clusters. So yes, we see clusters. Gaps. You were correct. We see no gaps. There is a peak. That is the peak. So we see that. There is almost always a peak. And if there's 2, I'm pretty sure you can still count both as peaks. And then it is not symmetric. Excellent. Now, what we would say with it being not symmetric is just because the left side doesn't look like the right side, or the left side of our graph is more clustered than the right side of our graph, and all of that. Let's look at this one. Choose an appropriate measure to describe the center and spread of the distribution. Justify the response based on the shape of the distribution. So think about what we saw on this side. If it's symmetric, what do you use? So we think about that. Exactly. So as we look up, we are going to be using mean because it is symmetric. We see this, and no, there isn't necessarily a peak there, but it's just the easiest way. And exactly. So we see Lucy and Jenna said mean. Sophia, Michelle, and Hannah pointed out that our mean is 29. So excellent. That's exactly how we would do it. We would say, I would choose mean because it's symmetric and the mean is 29. You could even put in the IQR. If we solved it, the IQR is 1.7 years. So you can look at that. Daniel pointed out that he says that's not the mean, that's the median. It's also the median. It just so happens to be the median. And here's a trick of how we know it's the mean. If I added all of these up, essentially, they each cancel with one another. I know how stupid that sounds because we're thinking median, but because we have one data point on each side in exactly the same position. That 33 cancels with that 25. They're in the exact same spot. 32 has 2, and the next 26. This has 3, this has 3, this has 4, this has 4. So if you added them all together and divided by the number of points, you would find that the mean is that 29. It is also the median, however. Now, describe the shape of this distribution. So I want you guys to describe the shape of this one. So before you hit enter, I want you guys to write it all down. You're going to write if there is clusters. You're going to write if there are gaps. You're going to write if there is a peak, and you're going to write if it's not or if it's... I feel like I spelled it wrong. Yeah, I did. If it is symmetric. So I also want you to write if there is a cluster, where is the cluster? If there's a gap, where is the gap? If there's a peak, where is the peak? And is it symmetric or not? Who would again like to tell me, what kind of graph is this? So what kind of graph is this? Yes, Sophia and Lucy pointed out it is a histogram. How did we know that this is a histogram instead of being just a bar graph, just a line plot, just a box plot, anything like that? How do we know it's exactly a histogram? What tells us that it's a histogram? Exactly. So first of all, we got numbers on both sides, which we can have that with bar graphs, but it happens with histograms. But there is that one more thing. Yes, Michelle pointed out the numbers have the same numbers between them. It sounds silly, but each of these bars has the same range. 0 to 9, that's a range of 9. 10 to 19, that's a range of 9. 20 to 29, that's a range of 9. So we see that is a histogram. So let's go over this. Now, are there any clusters? Who would like to enter if there's any clusters? We can type that in. What clusters do we have? So we see here that this right there is our cluster. So exactly, as Liana said, we have clusters. Then we can also see here, we got a giant gap. Excellent. Then we almost always, if not always, have a peak. Now, I saw someone write that the peak was at 18. Now, do we think the peak is at 18? What do we think the peak is at? Exactly. Daniel got it right. Michelle got it right. Liana got it right. Nathan got it right. I'm sure more of you have it. It is at this point, the 20 to 29, because that's the data we're talking about. So Lucy and Ani, again, that's the data we're talking about. Yes, it goes up to 18. That's the amount we have. That's the tip. But the data we're talking about is 20 to 29. And we already know it is not symmetric. When we have those gaps, it tends not to be. And there is an outlier. So look at that. We come here and we know it is not symmetric, the whole thing, and there is an outlier. Let's look here. Describe the shape of the distribution. Can I describe it with clusters? No, because we can't see where most of our data is clustered. Can I describe it with gaps? No, because I don't know where there are gaps in data. Can I describe it with peaks? No, because we can't tell where the most amount of numbers are. This does not show mode. So that leaves us pretty much with the two choices, not symmetric, symmetric, whether or not it is, and if we have any outliers. So we do have an outlier, just to point out, I showed you. It's that asterisk right there that's outside of the range of data. And then, is it symmetric or is it not symmetric? What do we think? Exactly. Those who've answered, it is not symmetric. Look at this. This part is the left-hand side of my graph. This part is the right-hand side of my graph. We split down that median. So wow, this part is 50% and this part is also 50%. We have more data. This is funny, we can't necessarily tell, but we have more data clustered between that 150 and 200 because as we can see, 50% of our data is within those 50 points, as opposed to here where 50% of our data is between these 110 points. So we see that. That's how we would describe this data. We would say not symmetric, and we would say that's our outlier that we've got right there. So it's a great job. Here, describe the shape of the distribution. So we've got our options. So exactly, we see Liana says it is symmetric. Yes. So our graph is symmetric. Do we have any clusters? Do we have any clusters? Do we have any gaps? Do we have any peaks? And do we have any outliers? So first, do we have any clusters? So do we have clusters of data? A lot of you guys say yes. I'd actually argue for no, because while you could say, oh, well, most of the data is gathered there, yes, but that doesn't make it necessarily a cluster. In fact, that's what's leading up to the peak of our data. And the reason that it goes up and up is because that's a symmetric gap. So we do have a peak. Do we have any gaps? Obviously, we do not have any gaps. And do we have any outliers? No, we do not have any outliers. Thank you, everybody. You guys did a really good job hitting enter. So let's look at this last one. A distribution that is not symmetric is called skewed. A distribution that is skewed left, so this is important, a distribution that is skewed left shows data that is more spread out on the left side. So one that is skewed right shows data that is more spread out on the right side. If you're smart, you'd write this down in your science notebook or highlight it at least. Take really, really good notes because this isn't in a space that you would typically look. So we would see this. As such, how does this data look? Is it symmetric data first? Is this symmetric? Excellent. This data is not symmetric. We can see here, this is our median. That's the middle of our data, and it is definitely not symmetric. Lastly, is it skewed left or is it skewed right? Let's think. If this is our median, is it skewed left or skewed right? Yes, we got Lucy, Michelle, Liana typed in their answers fast. We got it. It is skewed left because look at how much more to the left there is. So it is skewed to the left. If there is more data on the left-hand side, then, or if it's not even and it's spread out more on the left-hand side, then we know that it is skewed to the left. If it is not even and there's more data on the right-hand side, then, or more spread out on the right-hand side, then it is skewed right. So that's really the whole lesson. It's whether or not you can tell if a graph is symmetric, if a graph is not symmetric, if you can tell if there's clusters or bundles, if there's gaps, stuff like that. It is just that easy. So your homework is page 895, problem numbers 1 through 4, by the way. And number 4 is very, 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 very easy.